there are several solar power plants in the Mojave Desert which supply power to the electricity grid. Insolation in the Mojave Desert is among the best available in the United States, and some significant population centers are located in the area. These plants can generally be built in a few years because solar plants are built almost entirely with modular, readily available materials. Solar energy generating systems is the name given to 9 solar power plants in the Mojave Desert which were built in the 1980s, the first commercial solar plant. These plants have a combined capacity of 354 megawatts which made them the largest solar power installation in the world, until Ivanpah Solar Power Facility was finished in 2014. Nevada Solar One is a solar thermal plant with a 64 MW generating capacity, located near Boulder City, Nevada. The Copper Mountain Solar Facility is a 150 MW photovoltaic power plant in Boulder City, Nevada. The Ivanpah Solar Power Facility is a 370 MW facility which consists of 3 separate solar thermal power plants just off Interstate Highway 15 on the Nevada-California border in the Mojave Desert. There are also plans to build other large solar plants in the Mojave Desert. Overview. The southwestern United States is one of the world's best areas for insolation, and the Mojave Desert receives up to twice the sunlight received in other regions of the country. This abundance of solar energy makes solar power plants a cleaner alternative to traditional power plants, which burn fossil fuels such as oil and coal. Solar power stations provide an environmentally benign source of energy, produce virtually no emissions, and consume no fuel other than sunlight. Some groups are also encouraging more distributed generation, or rooftop solar. In 2008, solar electricity was not cost competitive with bulk, baseload power. However, it does provide electricity when and where power is most limited and most expensive, which is a strategic contribution. Solar electricity mitigates the risk of fuel price volatility and improves grid reliability. Since then, costs have decreased to make solar electricity increasingly competitive. While many of the costs of fossil fuels are well known, others are indirect and difficult to calculate. These are traditionally external to the pricing system, and are thus often referred to as externalities. A corrective pricing mechanism, such as a carbon tax, could lead to renewable energy, such as solar thermal power, becoming cheaper to the consumer than fossil fuel-based energy. Solar thermal power plants can generally be built in a few years because solar plants are built almost entirely with modular, readily available materials. In contrast, many types of conventional power projects, especially coal and nuclear plants, require long lead times. Solar plants equals Solar One and Solar Two equals. Solar power towers use thousands of individual sun tracking mirrors to reflect solar energy onto a central receiver located on top of a tall tower. The receiver collects the sun's heat in a heat transfer fluid that flows through the receiver. The U.S. Department of Energy, with a consortium of utilities and industry, built the first 2 large-scale, demonstration solar power towers in the desert near Barstow, California. Solar One operated successfully from 1982 to 1988, proving that solar power towers work efficiently to produce utility-scale power from sunlight. The Solar One plant used water steam as the heat transfer fluid in the receiver. This presented several problems in terms of storage and continuous turbine operation. To address these problems, Solar One was upgraded to Solar Two, which operated from 1996 to 1999. Both systems had a 10 MW power capacity. The unique feature of Solar Two was its use of molten salt to capture and store the sun's heat. The very hot salt was stored and used when needed to produce steam to drive a turbine generator that produces electricity. The system operated smoothly through intermittent clouds and continued generating electricity long into the night. Solar Two was decommissioned in 1999, and was converted by the University of California, Davis, into an Arshankov telescope in 2001, measuring gamma rays hitting the atmosphere. Solar energy generating systems equals. Trough systems predominate among today's commercial solar power plants. 9 separate trough power plants, called solar energy generating systems, were built in the 1980s in the Mojave Desert near Barstow by the Israeli company Bright Source Energy. These plants have a combined capacity of 354 MW. NextEra says that the solar plants power 232,500 homes and displace 3,800 tons of pollution per year that would have been produced if the electricity had been provided by fossil fuels, such as oil. Trough systems convert the heat from the sun into electricity. Because of their parabolic shape, trough collectors can focus the sun at 30 to 60 times its normal intensity on a receiver pipe located along the focal line of the trough. Synthetic oil circulates through the pipe and captures this heat, reaching temperatures of 390 degrees Celsius. The hot oil is pumped to a generating station and routed through a heat exchanger to produce steam. Finally, electricity is produced in a conventional steam turbine. The SEGS plants operate on natural gas on cloudy days or after dark, and natural gas provides 25% of the total output. Nevada Solar One Nevada Solar One has a 64 MW generating capacity and is located in Boulder City, Nevada. It was built by the U.S. Department of Energy, National Renewable Energy Laboratory, and Axena Solar. Nevada Solar One uses parabolic troughs as thermal solar concentrators, heating tubes of liquid which act as solar receivers. These solar receivers are specially coated tubes made of glass and steel, and about 19,300 of these 4-meter-long tubes are used in the plant. Nevada Solar One also uses a technology that collects extra heat by putting it into phase-changing molten salts, which enable energy to be drawn at night. Using thermal energy storage systems, solar thermal operating periods can even be extended to meet baseload needs. Solar thermal power plants designed for solar-only generation are well matched to summer noon peak loads in prosperous areas with significant cooling demands, such as the southwestern United States. The cost of Nevada Solar One is in the range of $220 a year $250 million. The power produced is slightly more expensive than wind power, but was less than photovoltaic power. As photovoltaics became less expensive, some proposed CSP projects have been converted to photovoltaics projects. Copper Mountain Solar Facility The Copper Mountain Solar Facility is a 150-megawatt solar photovoltaic power plant in Boulder City, Nevada. Sempra Generation began construction of the plant in January 2010 and the facility began generating electricity on December 1, 2010. At its construction peak more than 350 workers were installing the 775,000 first solar panels on the 380-acre site. The power from Copper Mountain Solar Facility is being sold to Pacific Gas and Electric under separate 20-year contracts. Californian utilities were required to obtain 20% of their energy supply from renewable energy sources by the end of 2010, increasing to 33% by 2020. Nellis Solar Power Plant In December 2007, the U.S. Air Force announced the completion of the Nellis Solar Power Plant, a solar photovoltaic system, at Nellis Air Force Base in Clark County, Nevada. Occupying 140 acres of land leased from the Air Force at the western edge of the base, this ground-mounted photovoltaic system employs an advanced sun tracking system, designed and deployed by Sun Power. Tilted towards the south, each set of solar panels rotates around a central bar to track the sun from east to west. The 14 MW system generates more than 30 million kilowatt-hours of electricity each year and supply approximately 25% of the total power used at the base. The Nellis Solar Power Plant is one of the largest solar photovoltaic systems in North America. Sierra Sun Tower The Sierra Sun Tower is a 5 MW commercial concentrating solar power plant built and operated by eSolar, located in Lancaster, California. The project site occupies approximately 8 hectares in an arid valley in the western corner of the Mojave Desert at 35° north latitude. Fort Irwin Solar Project Fort Irwin Solar Project could have been the largest renewable energy project in the Department of Defense's history. The initial development plan projected more than 500 MW of renewable energy with 1 billion kilowatt-hours of clean, renewable solar energy generated per year by 2022. Construction began on one smaller installation, a 2.4 MW array at the new hospital, along with a contract for a 1 MW concentrating photovoltaic test installation and a proposal for a 15 MW traditional PV farm. Ivanpah Solar Power Facility equals. The 392 MW Ivanpah Solar Power Facility, located 40 miles southwest of Las Vegas, is the world unregistered trademark's largest solar thermal power plant project, which became fully operational on February 13, 2014. Bright Source Energy received a $1.6 billion loan guarantee from the United States Department of Energy to build a project, which deploys 347,000 heliostat mirrors focusing solar energy on boilers located on centralized solar power towers. In February 2012, Ivanpah was awarded the CSP Project of the Year by Solar Power Generation USA. Mojave Solar Project equals. The Mojave Solar Project is a solar thermal power facility in the Mojave Desert in California, about 20 miles northwest of Barstow. Surrounding the hamlet of Lockhart, Mojave Solar is adjacent to Harper Lake and the SEGS Euro-9 solar plant. The 250 MW concentrating solar power plant will cost an estimated $1.6 billion in total and should be completed in 2014. The developer, Abango, secured a $1.2 billion loan guarantee from the U.S. government for the project. The nominal 250 MW solar electric generating facility generates steam in solar steam generators, which will expand through a steam turbine generator to produce electrical power from twin, independently operable solar fields, each feeding a 125 MW power island. The plant should generate 617,000 MWh of power annually, enough power for more than 88,000 households, and will prevent the emission of over 430 kilotons of CO2 a year. Pacific Gas and Electric has agreed to a 25-year power purchase agreement. Antelope Valley Solar Ranch equals. The 230 MW Antelope Valley Solar Ranch is a first solar photovoltaic project now owned by Exelon in the Antelope Valley area of the western Mojave Desert. In September 2011, the project received a $646 million loan guarantee from the U.S. Department of Energy, and its construction was estimated to generate 350 construction jobs and 20 permanent jobs. It features an innovative utility-scale deployment of inverters with voltage regulation and monitoring technologies, which will enable the project to provide more stable and continuous power. Electricity from the Antelope Valley Solar Ranch project will be sold to Pacific Gas and Electric Company under a 25-year contract. Land use issues. A 2013 study by the National Renewable Energy Laboratory concluded that the average large photovoltaic plant in the United States occupied 3.1 acres of permanently disturbed area and 3.4 acres of total site area per gigawatt-hour per year. The average CSP plant in the U.S. occupied 2.7 acres of disturbed area and 3.5 acres of total area per GWH. A 2015 life cycle analysis of land use for various sources of electricity concluded that concentrating solar power had a land use footprint of 9.0 m2/MWH for Trough, and 14 m2/MWH for power tower. The concentrating solar footprint was smaller than that of coal power, but larger than the other sources studied, including ground photovoltaic, natural gas, and wind power. When considering land use impacts associated with the exploration and extraction through to transportation and conversion of fossil fuels, which are used for most of our electrical power, utility-scale solar power compares as one of the most land-efficient energy resources available. The federal government has dedicated nearly 2,000 times more acreage to oil and gas leases than to solar development. In 2010, the Bureau of Land Management approved 9 large-scale solar projects, with a total generating capacity of 3,682 megawatts, representing approximately 40,000 acres. In contrast, in 2010, the Bureau of Land Management processed more than 5,200 applications gas and oil leases, and issued 1,308 leases, for a total of 3.2 million acres. Currently, 38.2 million acres of onshore public lands and an additional 36.9 million acres of offshore exploration in the Gulf of Mexico or under lease for oil and gas development, exploration and production. Some of the land in the eastern portion of the Mojave Desert is to be preserved, but the solar industry is mainly interested in areas of the western desert, where the sun burns hotter and there is easier access to transmission lines, said Ken J. Arnett of FPL Energy, a sentiment shared by many executives in the industry. See also: deployment of solar power to energy grids, list of solar thermal power stations, renewable energy commercialization, solar power in California, list of photovoltaic power stations, renewable energy in the United States, renewable portfolio standard. References. Template, Butt.